In factoring to solve quadratic equations, we're really going to see the tie between the factoring that we did previously and the solving equations that we did previously, and see how to figure out the unknowns in a quadratic equation. So our target is that we will solve quadratic equations with something called the zero product property and by factoring. So you saw this slide on the last lesson, and there are a variety of ways that you can solve quadratics. You can do that by graphing, and that's where you see where it crosses the x-axis. You can use square roots, where you have the x squared on one side, and then you have a number on the other side. You take the square root of that. Another method that we're going to see today is factoring. So that zero product property. Boil this down to something really simple that you learned in like second grade. If a number times another number equals 0, then either the first number or the second number equals 0. So if something like this, x plus 3, which would be like the a value, if that times x plus 2, which would be the other value, equals 0, then either this bubble right here, x plus 3 equals 0, or x plus 2 equals 0. If that's not clicking, think about that again. Think about what could I put in here that's going to make this multiplied times this equal 0. And with your zero products, that means that one of those numbers was 0. That's why your zeros were not a multiplication table that your teacher made you memorize, because anything times 0 is going to be 0. So let's look at these equations here. If we were trying to find the solutions of these equations, what you can do is bust each of those binomials down into two baby equations. So I can say x plus 1 equals 0, or I could say that x minus 5 equals 0. I separated them down and set them both equal to 0, and then they're baby equations that you can solve. So here I'm going to undo adding 1 by subtracting 1 on both sides, and you already knew that the solution was -1. And on this other one, I'm going to undo subtracting 5 by adding 5 on both sides. And before I even went through all that, your brain had already figured out that x equaled +5. So put that back in there. If I did -1 plus 1, I get 0. So it doesn't matter what is happening over here. Like if I put -1 in there, I'm going to have -6. 0 times -6 is 0. Or if I put 5 in there, here our 5 plus 1 is 6. But in this other parenthesis, 5 minus 5 is 0. So 6 times 0 still gives me 0. So there are two possible solutions to this equation. Here is a different one. I'm going to split that up. Let's get a different color pen for that. First, I'm going to have 2y plus 1 equals 0. Then for my other one, I'm going to have y plus 14 equals 0. So for the first equation, it's a two-step equation. You may take a little bit longer on that one. You're going to subtract 1, so you're left with 2y equals -1. Then you would undo multiplying by 2 by dividing by 2 on both sides. So y equals -1/2. Whereas on our other baby equation, we're going to undo adding 14 by subtracting 14 on both sides. So then I'm left with y equals -14. So I have my two solutions there. So how does this apply to quadratics? Well, since we are trying to find the x-intercepts, which we know are also called the zeros, the roots, the solutions, that's really what we're trying to find, right? The solution, we need the x-coordinate when y equals 0. So take this graph right here. I've already taken that same equation we started with, x plus 3 times x plus 2. If that was set equal to y, it would look like this on a graph. It's shifted to the left a little bit, it's down, it is sunny side up, but I have a solution here at -3, 0, And I have another solution right here at -2, 0. What you should have noticed in the last lesson was the y-coordinate is always going to be 0 for the solutions. When you have a function like this, you have x values and you have y values. So if I put 0 in for y, then I'm solving for that x value. So how this fits in is I take whatever that quadratic is, I set it equal to 0, and then I'm able to solve to find x. So for the first baby equation, I subtract 3 on both sides. I get that x equals -3. And for the other baby equation, I subtract 2 on both sides, and I get that x equals -2, which we already knew were the solutions by looking at the graphs. So here we can see two different methods to solve the same equation. If you factor it out, which is that's what this part is, the factorization, you get -3 and -2. If you graphed it, which would be convenient if you had a graphing calculator, then you see the solutions there. So, but what about when it looks like this, where you have a squared term? What we've been looking at the last couple of slides, those were the factorizations. Well, we can get to the factorization. So we're going to solve a quadratic by factoring. So your first step is that you factor the quadratic. So I'm trying to make it look like I have the parentheses. So go back to your quadratic. I need to find something that multiplies to get -14, yet adds to get -5. So since 14 has to be negative, I have to have two different signs. So if I did -5 and 7, I add those together, not -5 and 7, whoopsie daisy. If I did -2 and 7, that gives me -14, but when I add that, I'm going to have +5, which is kind of what I'm needing, so I need to swap the signs. 2 and -7 would give me +5 when I add those. My first term is m squared, so I'm going to have m in the beginning of each of my binomials, so it's going to be m plus 2 and m minus 7, and that's set equal to 0. It's set equal to 0 because we're replacing that y value with 0 in order to find the zeros of the equation. So then step 2 is we're going to bust that factorization into two baby equations and solve. So I'm going to have m plus 2 equals 0. So then when I solve it, subtract 2 from both sides, I'm left with m equals -2. And then the other one be m minus 7 equals 0. So I put 7 in there, add 7, and I have m equals +7. So I have two solutions right there. And then here's probably the most difficult kind that you'll see. Sometimes you have to rewrite the equation in standard form before solving. In this one, it's not set equal to 0 yet. So what you're going to have to do is first write it in standard form, which means I need to move that -49 over to the left side of the equal sign. So in order to do that, I'm going to add 49 to both sides, which gives me x squared plus 14x plus 49 equals 0. Now that everything is on the left side, I'm ready to factor. Now, if you remember your special cases, you may be looking at this and saying, oh, 49 is a perfect square, and you realize that it is a special case. If not, it's okay. We can still do this. Let's go just a regular factorization. Set up my parentheses. My first term is x squared, so the only thing that can multiply together to give me x squared is x and x. Now, when I think about 49, I think about its factors. Only way I can get 49 is 1 and 49, which would add to be 50, not 14, and I can do 7 and 7, which would add to give me 14. And it's all going to be positive because everything is positive in my quadratic. So the factorization is x plus 7. Now, if you saw the special case, you saw x plus 2 squared. It was a perfect square trinomial. Either way, when you go to bust that factorization into smaller equations, your equations are going to be the same. So in this case, you only have one solution, which is okay. Think back to that graphic that we had where we showed the different places that the graph could cross the x-axis. This would be a case where if this were my axis, it's crossing like that. There's only one spot that it's crossing, and it's crossing at -7. Whereas on our previous quadratics that we've been solving, they may have looked something like that, where they crossed at 2 places. So keep those things in mind that we have learned previously, and that will help you to interpret what it is that you're doing now.